All right, let's cover a telescoping series. This series is like geometric in that I'm going to give you a series that is telescoping. You'll have to recognize that it is this particular pattern, and it is one of those that we actually can find the sum of. So let's start with, I give you this series, 2 over n squared plus 2n, and we can start when n equals 1 and go all the way to infinity. So the question is, does it converge? And I think at this point we've decided that this is kind of like a 1 over an n squared. And so it definitely converges based on like a comparison test or a p-series test. So if it converges, well, can we actually find its sum? So let's go by inspection. Let's see if we can figure this out. I mean, it's not geometric. It's kind of like a 1 over n squared, but we don't really know how to find the sum of those yet, so let's take a look. So if I just plug in 1, I get 2 over 1 plus 2, I get 2/3. 2/3 plus, okay, when I plug in 2, I get 4 plus 4, I get 8, and 2/8 is 1/4. Okay, plus plugging in 3, I get 9, 6, I get 2/15. Start to see any pattern yet? Let's plug in 4. I get 16. 8 is 24. I get 1/12. And it's going to go on forever, and you're just not going to be able to see a pattern. 2/3, 1/4, 2/15, 1/12. There's just nothing you're going to be able to see there. So we need a new strategy. And the new strategy is actually to use partial fractions. So we're going to take this and we're going to decompose it into its linear parts. Remember, that's what partial fractions does. So let's write this as 2 times n times the quantity n plus 2. And we're going to make the claim that we can write that as some a over n plus some b over n plus 2. I'm going to multiply everything by this denominator, which makes this 2 equal to a times n plus 2 plus b times n. Again, multiplying by the this denominator, both sides, cancels all the denominators. And now I'm going to say, okay, I'm going to find a and b, and again, this has to be true for all n, so I'm just going to let n equals to 0. And so I get 2 equals, if n equals to 0, this says that I get 2a. Well, that tells me that a has to equal 1. Now I'm going to let n equal to -2. Hopefully you've already watched the partial fractions video. I'm going to let n equals to 2 to make that go away. The left side is always just a constant 2, and then this is going to be -2b, which says that b equals -1. Okay, so then I know that this thing is really the same thing as 1 over n minus 1 over n plus 2. So this series, going from 1 to infinity of this, but I just proved that this is equal to this for all n. So instead of summing up this guy, let's sum up the equivalent, 1 over n minus 1 over n plus 2. And then let's think about how this will work. Now let's plug it in by inspection. And again, don't actually do the subtraction. If you do the subtraction, you're just going to go back to these guys, which is silly. All right, plug in 1, and you get 1 minus 1/3. Okay, that's what happens when you plug in 1. Again, I know that 2/3 is that, but that's not the point. Plus, plug in 2. I get 1/2 minus 1/4. Plus, plug in 3. 1/3 minus 1/5. Plus, 1/4 minus 1/6. Plus, 1/5 minus 1/7. Plus, and keep going, and you're like, oh, check this out. This is super cool. Again, don't think about these two. Think about matching the series and see if we can get anything to cancel. So see how this is a minus 1/3 and this is a plus 1/3? Well, those go away. Here's a minus 1/4 and there's a plus 1/4. Those go away. There's a minus 1/5 and a positive 1/5. Those go away. See how this would be a minus 1/6 and that next term would be a plus 1/6? They'd go away. And this is minus 1/7 and you'd get another 1/7. And all of those are going to have partners that cancel. And the only thing that doesn't cancel is the very, 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 very last term. But what is the very, very last term? Well, the last term is 0 anyways, because as n goes to infinity, the last term is 0, so who cares about that term? And so that whole sum, the only two things that survive in the whole thing are that 1 and that half, and so then the sum is equal to 3/2. And so it turns out that that sum is actually equal to 3/2. And again, this is the pattern of how you would telescope. You use partial fractions to turn this thing into this, and then you can write out those patterns and you can see. And you see how these were off by 2? This is n and this is n plus 2. And see how these had 2 surviving terms? You're going to notice that that pattern exists. If this would have been a plus 5, well then you would have had 5 terms survive, because this is going to be 5 bigger, so it would have got to the 5th term before it started to cancel, right? This 1 over n took to the 3rd term to match the original 1 over n plus 2. You can think about that. And I'll do another example where it takes 3 terms because they're shifted by 3. But again, all telescoping series rely on this same pattern. So let's say I had 9 over n squared plus 5n plus 4. And again, if you tried to write that out, you're not going to see any pattern. You're not going to be able to figure it out. We know it converges because it's pretty much a 1 over an n squared. And we're going to use partial fractions again to kind of break this down. So we're going to say this is n plus 1 times n plus 4. And that's equal to sum a over n plus 1 plus sum b over n plus 4. Multiply by that denominator, and I get 9 equals a times n plus 4 plus b times n plus 1, and I'm going to let n equal -1. So let n equal -1, and then I get 9 equals 3a, and that goes away. When n equals -1, that goes away to 0. So that tells me that a equals 3. And then I'm going to let, well, I might as well let n equal -4. And so I get 9 equals, that goes away, and I get -3b. That tells me that b is -3, which tells me that this is really 3 over n plus 1 minus 3 over n plus 4, which tells me that this original sigma then, I really can write it as the summation of n equals to 1 to infinity of 3 over n plus 1 minus 3 over n plus 4. I'm going to take that 3 outside. Summing up 3 over n plus 1 is the same thing as multiplying the sum by 3 and summing up 1 over n minus 1 plus 1 over n plus 4. Hopefully you're okay with that. Again, factoring something out from a sigma is something that we should be very comfortable with from 1 to infinity. Okay, so 3 times, okay, now I'm going to start my parentheses. I'm going to plug in 1, and I'm going to get 1/2 minus 1/5. My first guy, plus, now plug in n equals to 2, 1/3 minus 1/6, plus 1/4 minus 1/7, plus 1/5 minus 1/8, plus dot dot dot. And hopefully you can see all the cancellations now. 1/5, 1/5. Where is my half, my third, my fourth doesn't cancel. Oh, I probably should have just done one more term. This next term, see how this is 1/5 minus 1/8? This next term would have been 1/6 minus 1/9. And then you would have seen that the 6th cancels with the 6th and the 7th cancels with the 7th, but all of those are going to have partners. And the only surviving terms are this guy, and this guy. Again, 3, and if you look at how these are shifted, n plus 4 and n plus 1, this is 3 bigger than this, so it took 3 surviving terms, and so then this one matched up with that one. And so then the sum, don't forget that 3 out in front, 3 times 1/2 plus 1/3 plus 1/4. Whew. So that is, let's make those 12ths, right? 6/12 plus 4/12 plus 3/12, and that's 13/12. And that is just a 4, so 13/4 is my sum. And that's how you do telescoping. Telescoping series are all that same thing, in which you start out with typically some quadratic. We know it converges, and the question is, what does it converge to? We rewrite this
as the sum of linear things. I'm always going to factor that 3 out in front just to make the pattern seem easier. And again, then you plug in n equals to 1, 2, 3, 4, 5, 6, as many as you need, and then you can see which terms actually cancel, and then the surviving ones are the only ones left. Remember, the last term is 0. This term goes to 0 as n goes to infinity, and then don't forget that 3 out in front, so it was 3 times the sum of those 3 remaining terms, and I get 13/4. And if you really wanted to check it, you could plug in all these random fractions and just plug in, 100 of them, or your calculator might even be able to do that on its own and get 13/4. All right, so that's telescoping.